You are looking at an idea that was never supposed to leave the drawing board. A spacecraft powered not by fuel, not by electricity, but by nuclear explosions. Thousands of them, one after another. This is Project Orion. And if it had worked, it would have changed everything we know about space travel. In the late 1950s, the atomic age had begun. The space age was just emerging, and in between those two worlds, a group of physicists asked a terrifying question. What if we use nuclear bombs? Not for war, but for propulsion. The idea was simple in concept, almost absurd in execution. A massive steel plate, called a pusher plate, attached to the back of a spacecraft. Behind it, nuclear bombs would be detonated in sequence. Each explosion creates a wave of plasma and radiation. That wave slams into the plate, pushing the spacecraft forward. And then, it happens again. And again. A controlled chain of nuclear blasts propelling a ship through space at speeds no chemical rocket could ever achieve. Estimates suggested it could reach Mars in weeks, Jupiter in months, and the outer solar system in a single human lifetime. To understand how radical this is, we need to understand current space travel. A chemical rocket is limited by energy density. You burn fuel, you throw mass out the back, and you push forward. But most of the energy is wasted. Nuclear fission changes that entirely. When an atom splits, it releases millions of times more energy than chemical fuel. In theory, a single nuclear pulse could replace tons of rocket propellant. But Orion was not just an engineering idea. It was a political nightmare, because to work, it had to do something unthinkable. Detonate nuclear weapons in Earth's atmosphere. Early designs even imagined launching Orion from the surface of Earth itself. It sounds like science fiction, but it wasn't. The math worked, the physics worked, the engineering might have worked. Even NASA scientists and physicists like Freeman Dyson were seriously involved in the concept. Dyson later described Orion not as impossible, but as too easy. Too easy to build something powerful enough to leave Earth orbit in hours. Too easy to build something that could reach Mars before politics had time to catch up. And too dangerous to ever test. Because once you begin detonating nuclear devices in sequence, there is no halfway point. Orion would not glide into space. It would be hammered into it. And yet, there was a problem even deeper than engineering. It was visibility. A launch like Orion would not be subtle. It would be visible for hundreds of kilometers, and radioactive fallout would become unavoidable. This was the beginning of the end. The Partial Test Ban Treaty of 1963 banned nuclear explosions in the atmosphere, underwater, and in space. Orion was grounded, not because it didn't work, but because it worked too well. And yet, the idea never truly disappeared. Because once you understand Orion, you can't unsee it. Where chemical rockets struggle against the limits of energy, Orion simply removes the limit. And that leads to uncomfortable questions. If we had built Orion, what could we reach? The nearest stars would still be out of reach, but the solar system would no longer be distant. It would be accessible. Voyages to Saturn would become routine, even interstellar probes, possible. But the cost is the question that ended it all, because every pulse is a nuclear detonation, and every detonation leaves a mark, not just on engineering, but on politics, on law, on the planet itself. So Orion became something strange, not a failure, but a forbidden success, a concept too powerful for the world it was invented in. And yet today, as we look again at interstellar travel, Orion quietly returns in scientific discussions. Because the problem has not changed. Space is still enormous, and chemical rockets are still slow. Even modern spacecraft take months to reach Mars, years to reach the outer planets, and tens of thousands of years to leave the solar system entirely. Orion breaks that timeline, and that is why it still matters, because it shows something fundamental about physics. If you are willing to use extreme energy, the universe opens up.